Arvind Reddy is saying okay, and Shubhas Electrical. So please let me know, all of you guys, Soumyabal, Karan Gupta, Madhu, and Rufina Begum, all of you, please let me know is everything is clear, audio as well as video, so that we are going to start the session. So I am waiting for your comments. Yes, Nikhil Jain, very good. Right. So as we are discussing about the champion series, this is going to be the second lecture, especially in control system subject. As you all know, we are going to discuss about RH criteria and root locus. As I was saying earlier also, by the time you have already done reasonable practice in control system, so I will consider you as you already know the subject little bit. Let's discuss like a champions. Okay, so I will try to put all possible concepts and mix the concepts and twist and present to you, so that you will really enjoy the class. Okay, right. So yes, sure Shubhash. So I think today little bit you have to manage, and from tomorrow onwards we are going to take care about your problem. Clear? So moving ahead, these are the credentials. As you all people might be knowing about me, but there are some students who might be there in the class who are not aware of me. So these are the credentials all put together. I have an experience of 12 plus years teaching for both ESE as well as GATE. Up to now, I have guided more than 50,000 students all across the country, and especially in the subjects of control system, circuit theory, and industrial instrumentation. So we are going to discuss about the second class in champion series. But before that, I would like you to note down the entire series of the chapters here. We have already done with this, and we are going to discuss about this and this, because the time response is also completed in yesterday's session, and I feel that you guys really enjoyed a lot in yesterday's session, isn't it? Right? So let's continue the same thing, and never ever judge class with a first question. Okay, so the first question always it starts like basics, but after that I will go deeply, after that I will go too deeply, and by the time when I complete the class, you will going to get a lot of concept out of it, and that is my guarantee. Okay, so guys, are you ready? So this is the first class. In fact, the first question in the RH criteria, it was given like that. It's a simple question, but I just want to get the momentum by solving simple question, and then we will going to enter into the difficult questions. Okay, so the question statement is, consider the feedback control system shown in the figure below. First question, find the function, in fact find the transfer function of the system and its characteristic equation. And second is, use the Routh Haurwitz criterion to determine the range of K for which the system is stable. So both the questions we need to solve. Right, very good. Right. So Karan, thank you Karan, thanks for your feedback. Now let's solve for the transfer function first and identify the characteristic equation. After that we need to get the value of K for which the closed loop control system is stable. So first of all, you must understand that Routh Haurwitz criteria is used to measure the stability of what? Closed loop control system. So where do we start first? We need to identify the transfer function. How do we identify? So the transfer function of the closed loop system or closed loop system transfer function, we all know that we will be writing like C of S by R of S. So first write down like this and move ahead. And all of you know that this is a very simple block here. So I can combine this and put it together. So what is the reduced block diagram of this highlighted portion? So it is, I can say this as a G of S here, G of S, and here I can put this as a H dash of S here. So if so, what is the block of this one? So G dash of S divided by 1 plus G dash of S into H dash of S, correct? So whatever is there in this highlighted portion, I am writing only that. So Arvind Reddy, I am extremely sorry. Yesterday what happened is I just discarded the PDF here. So I will again form the PDF and send it to you. Don't worry about that. Today definitely I will going to give it to you, PDF. Don't worry. I am extremely sorry for what happened in the yesterday class. Okay. So G of S, it is going to be 1 by 2 here and divided by, here you will be having like, so 1 by 2 into 3, right? So what you will going to get all the way here? So it will be equal to 1 divided by 5, which is actually nothing but 0.2. Clear? So this is going to be 0.2, right? So now once you get that as a 0.2, obviously I can say all put together here you are having 0.2. Therefore I can write down straight away here as 0.2K, because whatever 0.2 we have here, that I can write down directly here because both will going to multiply. Then we can easily find out that this is going to be equal to G of S divided by 1 plus G of S into H of S. This is so simple to understand, right? However, we require only characteristic equation, but let's go and find the transfer function as it demands the question. So you may be thinking that this is a very simple question. I too agree that this is a simple question, but as I was saying, wait for 5 minutes, we will going to get a very good questions. Okay. So what is g of s here? So it is going to be 0.2 all the way k into, I can say s plus 1 all the way divided by, we are having s here, whole divided by 1 plus g of s into h of s. Again 0.2 k into s plus 1, of course, divided by s, of course, into 1 divided by s plus 0.1 here. Clear? Now what you must understand is we require only the characteristic equation. That means we require only the denominator here, right? So let me move one step forward and calculate the characteristic equation straight away here. So the characteristic equation, as I was saying, 1 plus g of s into h of s is equal to 0, which is actually nothing but what? So look at that. So the denominator we must equate it to 0, right? So therefore it will going to become like 1 plus, just get it me here. So 0.2 k into s plus 1 all the way whole divided by, what will be there in the denominator? S into s plus 0.1, correct? So s into s plus 0.1. So I can write down this as s into s plus 0.1. As I was saying, it must be equal to 0 before going to apply the Routh Haurwitz criteria. No one got the answer up to now. Please let me know what is the answer here. What is the range of k where the system is stable here? It is a simple question. I expected the answer, but no one has given the answer up to now. So therefore I should consider this as a good question. Okay. So it is equal to 0. So what you will going to get here? So it will be equal to s square. Of course, this is going to be 0.2 k plus 0.1 all the way whole into s plus 0.2 k. Clear? So this is considered as a characteristic equation here, right? So we have just solved the characteristic equation up to now, and once we get the characteristic equation, then we must form the Routh array here. So how do we form the Routh array here? So s square, first write down s square here, and then s power n undoubtedly, and then s power 0, correct? So therefore we can say Routh array starting with the coefficient of s square, how much it is going to be? 1. So let me write down 1 and then leave the coefficient of s and then move to the next one here. So it is going to be s power 0 here. So what is the value here? So this is going to be 0.2 times of k here, and next s power 1 coefficient I can say 0.2k plus 0.1 here and then 0 here. Then what would be the coefficient of s power 0? It is dead simple, right? So the coefficient of s power 0 is already there here. So we need not to do anything here, readily available here. So 0.2k here. Now tell me for which value of k the closed loop system is stable. Any one of you? Why no one is answering? Are you able to hear me properly? Guys, respond here. Yes, yes, k greater than 0, right? So now we will see here, we have to understand the fact that, to get the closed loop system to be stable, or if you want the closed loop system to be stable, then the first column of Routh array, all the elements must be greater than 0, correct? So therefore here 1, I am very sure 1 is a positive number, no problem, and 0.2k, it must be greater than 0. So therefore I can say 0.2k must be greater than 0. So therefore k greater than 0. That is one thing. And now look at this. This value also must be greater than 0 here, correct? So therefore, how can I write down this one? So the 0.2k, of course, just 0.1, it must be greater than 0. So therefore, I can say k must be greater than minus 1 by 2, which is actually nothing but k must be greater than minus 0.5. So any value where the k value is more than minus 0.5, the closed loop system is stable. But as we all know that, we will going to place the positive value of k. But you must also understand, this condition is saying that k must be more than 0.5, and this condition is saying that no, k must be greater than 0. So what would be the correct answer here? The correct answer is positive value of k. Any positive value of k, or for any value of k which is greater than 0, the closed loop system, means the entire closed loop system is stable. I too agree this. That is, this question is very simple. I frankly agree with this. But to get the momentum, I have solved this. Now let's go one step beyond this and go to the next question. As you all know that I will mix the control system with the circuit theory and analog electronics all. Now we will see one step ahead and look at the same theme in the different way. Nikhil Jain, are you ready to take up this question? And Dasari Kola, you try to answer this question. Look at the statement of the question. This is a good question. Find the value of the feedback resistor of the non-inverting amplifier such that the closed loop system is stable. Okay, we will take this question for 10 minutes. right? And I will discuss all different varieties of possibilities here. Okay, so try to answer this one. So R1 is equal to 1 kilo ohm, and you must understand that in the feedback we have an amplifier, sorry, in the forward path we have an amplifier, and this is considered as a plant transfer function. Okay, this is considered as a plant transfer function, and this is considered as an amplifier, correct? So now we all know that the error signal may come here, and assume that the error is voltage only. Let's assume that whatever we are getting here, that is the voltage. All parameters here are considered to be voltage. Now what I do here is, maybe this voltage might be given to this one, clear? So it is connected to this with ground as a reference. So what does it mean? Inherently it means that I can say that whatever the error voltage we are applying here, that is actually nothing but the voltage given to what? Given to non-inverting terminal here, clear? Given to non-inverting terminal here. So these kind of questions are very, very good questions. You have to think practically and apply that concept. Many times we will get the answer for k is equal to 6, k is equal to 4, but we don't think, majorly students won't think from where you will get that k. On paper you will be having k is equal to 4, k is equal to 6. That is nothing but controller gain. But how do we get practically that? Practically we will be getting that by using a amplifier circuit, clear? So let's get into the topic here. So now you all must understand that whatever the voltage we are going to get here, so suppose if I say that is V0 of S here, so this all the way the function of the controller here, let me say GC of S here, and this could be considered clearly as a G of S here, clear? So GC of S, which is called as a controller transfer function, what is that value here? Here it would be written as V0 of S divided by V of S. That means output of the controller divided by error signal. What is this value here? You all know that this is going to be 1 plus RF by RI here, correct? 1 plus RF by RI. So I have taken R1 here, so let me take R1 here, correct? So therefore this 1 plus RF by R1 could be considered as a K. This is considered as a K. So that means whatever the value of K we are getting in control system, that is actually nothing but the gain of some amplifier circuit in analog electronics, clear, in real time. So now we need to evaluate the K value first, where the closed loop system is going to be stable. So that means now what I do is I will ask you to change this entire function as a K, right? Change this entire function as K. Any one of you easily can understand that the feedback is equal to 1. Still the gain of the feedback is 1. H of S is still equal to 1, and in the forward path we have K as well as we have this function here, which is nothing but 1 by S into S plus 1 into S plus 2. Why no one has given the answer? I expected the answer from you, right? Anyway, let me go with the characteristic equation first of all. So characteristic equation is 1 plus, now we have K here, K into G of S into H of S, correct? That must be equal to 0. So moving ahead, I can say clearly that 1 plus K is there, no problem, divided by S into S plus 1 into S plus 2, all the way, that must be equal to 0. So moving ahead, you will have the characteristic equation as S into S plus 1 into S plus 2, of course, plus K is equal to 0 here, correct? So there are so many questions we will going to think and we will going to discuss now. Just try to apply your common sense, okay? Right. So now we can move forward here and place it clearly that it is going to be S square plus S all put together, this is into S plus 2 and plus K is equal to 0 here, correct? So moving ahead, what you will going to get? S cube, of course, 2 times of S square plus S square, that is going to be 3S square, and plus 2 times of S plus K, that would be equal to 0, correct? So this is called as a characteristic equation, right? But the question is, what is the value of K for which the closed loop system will be stable, correct? So now if you look at this characteristic equation, it is so easy, right? So easily we can plot on the RH criteria here, or else Routh Haurwitz criteria, or else even we can take the root locus support also, no problem. So I can say here S cube, and let me take this as a S square and S power 1 and S power 0 here, correct? Now look at that, what is the S cube coefficient? 1, and then leave next coefficient, this is 2, and leave next coefficient, this is 0, and here we will be having 3, and here we will be having 0 and 0 here. Now here 3 into 2, 6 minus K divided by 3, so therefore it can be written as 6 minus K divided by 3, this is 0 and this is 0, and here we will be having K. So one good thing here is every one of you know that K should be positive here. So I will be saying K is positive. No issue, right? So now you all must understand that 6 minus K should be greater than 0, because for the stable system, all elements in the first column must be greater than 0. So 6 minus K should be greater than 0. So that means K should be actually less than 6 here. K should be less than 6 here. Now I am asking a simple question. K should be less than 6. So that means any value of K from 0 to 6, the system is stable. Just as I was saying, this is not the final question. Okay, I will enhance this question. I will discuss so many other questions from this question. So please stay till the end. Okay, 0 less than K less than 6, right? Now this means that if K is equal to, if K stands in between 0 to 6, then it is stable, correct? And if K is equal to 6, what will going to happen, anyone? If K is equal to 6, what will happen? If K is equal to or K is greater than 6, what will going to happen? Any one of you? Think logically and tell me. So K is equal to 6, then it will become marginally stable system. Then you may ask a question, sir, how do you know this, right? So wait, I will tell you, marginally stable system, and this will going to become unstable system. How do you know this one, sir? So please see here, all of you. Now just let me ask you a simple question. You all know that this is a characteristic equation, right? So in case if I plot the pole 0 graph here, how it looks like in root locus here. So look at that. What is your G of S into H of S here? Can you see here? So look at that. In case this is your total function of G of S, and we have K here. K is multiplied with this one, right? So in fact, I can say now the function has like K divided by S into S plus 1 into S plus 2 here, correct? K divided by S plus 1 into S plus 2, right? Very good, excellent, critically stable, right? K will be less than 5 kilo ohm, right? So now if you look at the root locus plot, right? So let us look at the root locus plot also. That means here, yes, I know that you people can get the answer so easily, but I am going to discuss one step beyond this. What was the first pole we have? S is equal to 0. What was the second pole? -1 and -2 here. So moving ahead, we can say the first pole is here 0, and second pole is at -1, and third pole is at -2, correct? Now those students who know how to plot the root locus plot, you might be understanding that this pole will all the way travel to the -infinity here, this side, correct? And this pole will all the way travel this way, and this will travel in this way. Both will going to meet together and they will enjoy for some time, and then breakaway point will come. One line it will go like this, and here it will go like this, correct? So I am sure that you all know this one, right? So usually the K value at which the root locus cuts the imaginary axis here, this K is actually nothing but 6 here. And similarly here also we are going to have K is equal to 6. Suppose in case if K goes beyond 6, what will going to happen? Obviously the system will become unstable. Why the system will become unstable? If K is more than 6, then I am very sure that the roots of the characteristic equation will come onto the right half of S plane. Clear? So that's why I told you that for K greater than 6, the closed loop system is unstable. K 0 to 6, the closed loop system is stable, because all the root locus branches will be in the left half of the S plane. Clear? So that's the basic idea. But what was our question? Our question is, find the value of feedback resistor where the closed loop system is stable. Now I understood that the K should be less than 6 here, correct? K should be less than 6. Therefore I can say RF by R1, that should be less than 6 here, less than 5. I am extremely sorry here. So it is going to be 1 will take in that side. So we will be having here only 5 here. So what should I say? RF should be less than R1 into 5. So R1 is how much? That is 1 kilo ohm here, 1 kilo ohm. So therefore RF must be less than 5 kilo ohm. This is the answer. I think most of you already got this one, right? I appreciate the students who have already done this, undoubtedly. But I would like to ask a question here. Have you seen here? This is a feedback resistor. Why? Feedback resistor of what? It is the feedback resistor of non-inverting amplifier. Now if I ask a question, tell me what is the value of feedback resistor here such that we will going to get a sustained oscillation in impulse response. Answer to this question, every one of you. I am asking what is the value of K here for which, okay, for which the closed loop system response, impulse response, provides the sustained oscillation. Provides the sustained oscillation. Any one of you? Nikhil Jain, Arvind Reddy, Soumya, what would be the answer? When we will going to get sustained oscillation? Now look at the beauty of this. When k is equal to 6, if you find the roots here, you will be having 2j here and minus 2j here. How do we get k is equal to? Just substitute k is equal to 6 here. Substitute k is equal to 6, right? Then you will going to solve this. If you solve this, you will be getting 3 poles here. One is S1 is equal to plus 2j, S2 is equal to minus 2j, and can anybody solve for S3 here? So what would be the value of S3? Take your pen and paper and try to tell me what is the value of S3. I will like the students who made the S3 fast here, so make it here. So that means at k is equal to 6, we have 2j here and minus 2j here. Any one of you? What is the value of S3? Third pole, especially when we substitute k is equal to 6 here. Otherwise, yes, k is equal to 6. There is a one important point. That's why I'm showing, I want to show it to you, right? So here, yes, so 1 and then 3 here, of course, it is going to be 2 and then again this is going to be 6. So therefore, if you solve this, you will going to have first one is minus 3, right? And this is minus 3, okay? So right, minus 3 and 1.4, yes. This is going to be root 2. I am extremely sorry, right? So here we are going to have root 2 into j and this is minus root 2 into j. So that means this is root 2 into j and minus root 2 into j and this is minus 3. Now what I want to ask here is, when one of the pole of the closed loop system, now it is lying at minus 3 here, and when the value of k is equal to 6 here, correct? So that means roots of characteristic equation. One of the root of characteristic equation is lying at minus 3, one is lying at root 2j and another one is lying at minus 2j. Now we have a concept called dominant pole concept, correct? What do you mean by dominant pole? The poles which are near to the j omega axis, isn't it? As root 2j and minus root 2j both are on the j omega axis, I can consider that these two are the dominant pole and I can say, yes, we can neglect this for time being because it is far away from the j omega axis. Then you can say clearly that we are having a complex conjugate pole on the j omega axis. Then what should I say? It looks something like, k divided by s square plus 2, correct? K divided by s square plus 2. This is the pole. Then tell me what is the impulse response? It will going to oscillate. When the value of k is equal to 6, it will going to behave like an oscillator and all the way you will going to get oscillations like this, and the frequency of this will be equal to root 2 radian per second here. Clear? The root 2 radian per second you will going to get. This means that if k is equal to 6, as the poles of the closed loop system are coming onto the j omega axis, I can say the closed loop system is marginally stable. If the closed loop system is marginally stable, then the impulse response will sinusoidally oscillate with the frequency of root 2 radian per second. Is it clear or not? Every one of you please let me know. Only Manoj is responding, other people are not responding. Where are Sheki, Arvind Reddy and Rufina Begum? Where are you guys? Right? So that means it is your obvious choice that if you can have k is equal to 6, you will going to get omega is equal to root 2 here. Clear? So moving ahead, how to get k is equal to 6 here? K is equal to 6 you will going to get by placing RF is equal to 5 kilo ohm here. Clear? RF is equal to 5 kilo ohm. That means if you place RF is equal to 5 kilo ohm, all the way k will come equal to 6. Correct? If k is equal to 6 here, then the closed loop system almost it will provide the sinusoidal or sustained oscillation like this. Clear? Sustained oscillation like this. Right? Yes, yes, very good, very good. Now, have you really understood this? It means that though we don't have any L, because yesterday we have discussed that in a circuit, if you have inductor and capacitor, there is a possibility to have an oscillation. That's what we discussed in yesterday's session. But what is the meaning of this one here? Even though you don't have L and C circuit here, even though we don't have L and C circuit here, just by placing the feedback resistor value which is equal to 5 kilo ohm, there is a scope to get sustained oscillation here for impulse response. Interesting or not? Have you really enjoyed this or not? Tell me all of you in the comment section. This is the way sometimes a marginally stable system also can be useful for us to provide the sustained oscillation. Of course, it has happened only with the assumption that we have considered this as a dominant pole and we have neglected. Clear? But in general, it will not going to provide the pure oscillation. Clear? So this is exactly the way how you should think. Everything is connected at the end. Yet either it might be analog electronics or control system or circuit theory. All you need to mix and think. Then you will be called as an engineer. Okay? You will be called as an engineer. I hope you enjoyed this question. Have you enjoyed it? Yes, sir. Good question. That's why I'm saying that it will be connected and you will going to think one step behind this. I mean beyond this. I'm very sure you will not get this kind of questions anywhere because morning to evening I am preparing these questions. Right? So moving ahead to the next question. Find the value of product R1 into C1 for which the angle of asymptotes, the angle of asymptotes should become plus 90 and minus 90 degrees respectively. This is also a good question. So it takes some time. Okay, think logically and tell me, right? Sir, please share your Telegram link. Okay, Telegram link at IN Guru 2022. You can keep, or else simply like you can keep IN Guru, you will going to get my link, you can go there, right? So yes, now tell me here all of you, how do we proceed here? Thank you very much, Manoj. I think you really like the class, right? So here we have an integrator. Again, let me call this as a V of S, and this is really a very good question. This would be really a very good question. Today we'll spend some little bit time because as you guys are seems to be so interesting. Let me go one step ahead here, right? Now you can understand here the same transfer function I have taken, but what we have done here, so instead of using non-inverting amplifier, what is this circuit? Can anybody say what is this circuit now? What is this circuit? Soumya Bala, what is this circuit? This is going to be considered as a RC circuit. In fact, in general it is called as a integrator, correct? Now I will ask a simple question. Suppose if I say this is V0 of S here, so what is this controller now? You are saying that this is a integrator, correct? So what would be the transfer function of this one now? So GC of S, right, that is equal to V0 of S divided by VE of S, isn't it? V0 of S by VE of S. What is this here? 1 plus feedback resistance divided by, input resistance, that is R1 here. So feedback impedance is how much? Because here there is no resistance, we have impedance here. So it can be written as the impedance of the feedback here is 1 by S into C1 here. Let me write down, divided by what else you are going to have here? So we are going to have R1 here, correct? We are going to have R1. So 1 by S into C1 divided by R1. So how much you will be getting here? It will become like 1 plus 1 divided by S into R1 into C1 here. Am I right? So look at that. Are you able to see here? Yes, yes, this is an integrator. So let us see what will going to happen if I put the integrator here. Okay. When you put the integrator like this, now I am very sure here. So still, even now also, how it will going to become now? So here, S into R1 C1 plus 1 divided by S into R1 C1. This is the way how you will be getting. Am I right? This is the way how you will be getting. Now, let me assume that here we have a function here. Let me call this as a GP of S, which is called as a plant transfer function. Correct? So now GC of S is there in the forward path. This is called as a controller transfer function and this is called as a plant transfer function here. So please look at everything is correct here. So ZF feedback resistance is 1 by S into C1 divided by the input resistance is R1 here, correct? Yes. Moving ahead, what you can say, all put together your G of S would be equal to GC of S, that is controller transfer function, into the plant transfer function, right? So what is GC of S now? GC of S is all this, a lot of things are there here. 1 plus R1 into C1 divided by S into R1 into C1, of course, whole into, what was there here? This GP of S, right? So GP of S is how much here? 1 divided by, of course, we have like S into S plus 1 into S plus 2 here. Clear? Now, what was the question? The question was, find the value of R1 and C1 where the angle of asymptotes will become plus 90 and minus 90. See, sometimes there might be a chance that it may not be possible also. Okay, don't try to feel that, okay, sir, how to calculate the third degree equation without calculator. So it's not possible because most of the times we cannot get so easily the answer. You require the calculator. So don't go there are a lot of procedures, long division method and all these things, but it is slightly difficult. I suggest that use the calculator, because in GATE they will give the calculator to you, right? So now in case if you look at, if I keep like R1 into C1 is equal to 1, then tell me what will going to happen here. It will going to become like G of S is equal to, right? G of S is equal to 1 plus S whole divided by S, of course, into 1 divided by S into S plus 1 into S plus 2 here. Clear? S into S plus 1 into S plus 2. Maybe this would be out here now, correct? This would be out here. So therefore what you will be getting here? 1 by S square into S plus 2, correct? 1 by S square into S plus 2. Now you may ask a question to me, sir, why should I take this one as like R1 into C1 is equal to 1? I will take R1 into C1 is equal to 2. Okay, you take it that. So one pole and one zero must cancel. That is what my aim. So this is called as a pole zero cancellation. This is called as a pole zero cancellation. What is happening because of the pole zero cancellation here? So because of the integrator now, one of the zero will going to cancel the pole present in the plant. What is the advantage of that? Will you get any advantage? So let us see what will going to happen. Now finally we have a function like 1 by S square into S plus 2, right? So if you have 1 by S square into S plus 2, and if you look at the pole zero plot, right? So the pole zero plot in the S plane, right? So here we have sigma here, and here we have minus sigma here, and this is going to be j omega, and here we do have minus j omega here, correct? Agree with me? There is no doubt up to here. Now there are two zeros here, so one zero here and one more zero here. Two zeros, two poles are there here, two poles are there, and there is one more pole which is exactly locating at a minus 2 here. Clear? Now you tell me, is it really possible here to get an angle of asymptote is equal to plus 90 and minus 90? Think logically, right? So it doesn't mean that every question you will going to get the answer ABCD, okay, right? So I was expecting at least one of you will going to give the answer. It is not possible. Many of you are struck at some point, right? I was really expecting that at least one of you will say that no, it's not possible, okay? So root locus shifts towards left if pole is cancelled. Fine, whatever it happened, finally we have like this, right? I'm asking that, is there any scope here to have, angle of asymptotes is equal to plus 90 and minus 90 or not? Tell me. So still you are in confusion, big confusion. Number of poles is equal to 3 and number of zeros are equal to how much? There are no zeros here, correct? So poles are 3 and zeros are 0. Then what would be the angle of asymptote now? Now if you calculate the angle of asymptotes, how much you will going to get? So you will be like 2k plus 1 into plus or minus 180 here, plus or minus 180 into 2k plus 1 divided by P minus Z minus 1. That means number of poles minus number of zeros minus 1. Correct? So, sorry, I'm extremely sorry here. 1 second. Right? So, here, yes, P minus Z. That means number of poles minus number of zeros here. Correct? So, this would be taken as P minus Z here. Now, tell me, in this case, what will going to happen here? P minus Z, all the way we know that is plus or minus 180 degrees into 2k plus 1, correct? 2k plus 1, P minus Z, number of poles minus number of zeros, that will be equal to 3. So you will be having like plus or minus 180 degrees into, obviously, so 60, plus or minus 180 degrees divided by 3. How much it will be? It will be so simple here. So you will be having plus or minus 60 here, 60 degrees into 2k plus 1. Now tell me, is there any possibility to have angle of asymptote is equal to 90 degrees? Why? Because k will take an integer value. K can be here 0 or k can be 1 or k can be 2, right? So these are the only values that are possible in this case for angle of asymptotes, odd multiple of 60. So you will be getting the angle of asymptotes is equal to odd multiples of 60. You will be getting angle of asymptotes is equal to odd multiples of 60. If you get angle of asymptotes is equal to odd multiples of 60, how do you get the angle of asymptotes is equal to 90 degrees here, right? So the answer for this, of course, 4 options are there. One of the option is not possible. Clear? It is not possible. You don't get angle of asymptotes is equal to plus or minus 90 degrees. Why, Arvind? Then why you took this much of time? It is not possible. Once I say you are confident, no, you should be confident from your side, right? So that's why intentionally I have not given 4 options. There were 4 options. In that, option D is not possible. I was expecting answer from at least one of you. You all have done this, but you are not coming forward and saying this. So you should be confident about your answer, right? So the answer is not possible. But what you have understood here, if you use the integrator here, you will not be having 90 degrees and minus 90 degrees here, correct? So the answer is not possible. Good question again, right? So this is also a good question, right? Now you may be asking a question here, sir, I will not take R1 into C1 is equal to 1. Why should I take R1 into C1 is equal to 1? I don't take it. No problem, you take anything what you want. Even whatever you take it here, you will understand that you will may not be, just look at that, is it possible in the other way? Suppose if you take R1 is into C1 is equal to 2, or maybe you can take any value, then what will going to happen? Here in the denominator 4 poles are there, in the numerator 1 0 is there, correct? In the denominator 4 poles are there, numerator 1 0 is there, right? So in that case what will going to happen? Again P minus Z, that means 4 poles and 1 0, again P minus Z will be equal to 3 only, clear? So that means whatever the value you have taken for R1 into C1, right? So even if you take 4 here, okay, R1 into C1 is equal to 4, you will understand that at that time pole 0 cancellation may not be possible, but still you will going to get the angle of asymptote plus or minus 60 degrees odd multiple, clear? Right? So never seen this type of questions from anywhere. Yes, that's why I am saying that you should not miss the class, okay? Right. So I hope you really enjoyed this question. That means here for this application, integrator is not possible. All right, integrator, we cannot use integrator. Now you should think and tell me what would be the other way around. Is there any other way to support this one now? Now if you shift this capacitor to here and shift this resistor to here, एक बार check कर दो क्या हो सकता है. So just think about one step beyond others here. Just take one step and shift this capacitor to here and resistor here. Where are you, Rufina? Where are you, Madhuri? All of you, where are you? This method are tough but interested. Good, very good. Interested, right? See, these are the practical questions I am saying. Now you see all the way you will be able to understand how to connect the concepts, right? That is more important for gate. Okay, right. Now when you shift the capacitor here, resistor here, in that case, how do we write this overall gain here? Now this will going to change here. Let us try in that way. Is it possible or not? So what we can do here, okay? Then it will be really a very interesting question. So when I shift this 1 plus, feedback is going to be resistor now, R1, and here we will be having what? We will be having like SC1 here, correct? SC1, right? So sorry, I'm extremely sorry. Here again, you have to write here ZF feedback impedance divided by input impedance. So what you will get here? Feedback impedance is, because you have shifted the resistor to here, capacitor to here, correct? Then it will going to become like feedback, we have resistor R1 and here we have SC1. So what we will going to have now? So we will be having like 1 plus S into R1 C1 here, clear? Right? So you will be having like this transfer function. Now what I would like to ask here is, yes, in that case, if you shift this, then this is called as a differentiator, clear? Differentiator, right? Okay, this is considered as a differentiator now. Now एक बार check कर दो. Once, don't stop. You all are engineers. Think like engineers and think like champions. Okay, right? So don't say that I am discussing, very typical questions. You are champions. That's why I am discussing this. Now look at that. What will going to be the change that you can see here? Now all these things will not be there here. So let us see how the things will going to change here, right? So whether we will be getting angle of asymptotes or not, we will see here, required value or not. Now the most interesting fact is, now also no one is answered up to now. I was expecting you should answer this, right? Fast guys, fast. So now just look at here GC of S. What is GC of S now? Now GC of S is going to be 1 plus S into R1 C1, right? So therefore I can say 1 plus S into R1 into C1 here all the way, whole into what is GP of S? GP of S is this one all the way. So that is 1 divided by S into S plus 1 into S plus 2 here. Clear? S into S plus 1 into S plus 2. Now you can select if R1 into C1 is equal to, R1 is into C1 is equal to 1 or 2, anything is fine. 1 or 2, anything is fine. If it is so, then what is G of S here now? So g of s is equal to 1 plus s whole into 1 divided by s into s plus 1, of course into s plus 2 here, correct? Of course into s plus 2. So this will get cancelled. Then you will be simply having like, you know, g of s is equal to what? Anyway, h of s is 1. I am not so worried about that. 1 by s into s plus 2 here, correct? Right? 1 by s into s plus 2. Now think logically, one step beyond the others, right? So here number of poles are 2, open loop poles are finite poles are 2, zeros are 0. What are those poles here and here? Minus 2 and minus 0. Now what can I say? Here we will be having only one pole here. I'm very glad to see here. So therefore I can say here, yes, of course, this is going to be 0. Now tell me, all put together we have only 2 poles and zeros are 0. So this is, what is the value now? Plus or minus 180 degrees into 2k plus 1, correct? 2k plus 1 divided by 2. So how much you will going to get here? Now you will easily understand that yes, there is a possibility that k will be taking the value from 0 to 1 now. Now keep here k value, right? Odd multiples of 1. So you will be getting 90 and minus 90 here, right? So therefore I can say k value is equal to 0, k value is equal to 1, right? Then you will going to get all the way, this value is equal to, now it's easy to say plus or minus 90 degrees you are going to get here. Clear? So plus or minus 90 degrees you are going to get. That means now it's possible. Now it's possible. Angle of asymptotes can be 90 degrees and minus 90 degrees when we use the differentiator for this function. Clear? So is it interesting? Every one of you enjoyed, right? So intentionally I made the first one as a integrator to show you that it's not possible. But differentiator, what happened is differentiator added 1 0, correct? 1 0, right? So now you might have thought in the initial stage itself, because the differentiator will going to keep the transfer function like this. Why? Because if you want the angle of asymptote is equal to plus or minus 90 degrees means we must not have 3 poles here. We must have only 2 poles. P minus Z should be equal to 2. That means we should have 0 in the numerator. So that 0 is possible to create only if you have a differentiator here. Clear? So that is how we should design the practical system. Clear? That is how we are going to design the practical system. Now I have a question to every one of you. Okay? Is it interesting? Guys, you have to tell me, motivate me also, right? So the good part about this is we have cancelled s plus 1 and s plus 1 here. So it is done. So now the root locus might be all the way, it may come here, and then at the middle it will going to go in this way. Centroid and breakaway point both will become same in this case. Centroid and breakaway point both will become same. Clear? Now we will go one step ahead, right? Shall I take you to the next level, or you are feeling so difficult? Are you feeling so difficult? Are you feeling so boring? Are you feeling really interesting and challenging? Because as someone mentioned that these questions are new to you, but this is the way you should think. This is the way you should think to become a topper, right? Everybody can apply the formula, everybody can get the answer. What's new there, right? So you have to think differently, right? So very good. Yes. Now move ahead to the next one. Find the value of k for which the roots of the characteristic equation only lies in the, see, look at that question, look at clearly, only lies in the left half of S plane. Where are you, Soumya Bala? Where are you, Soumya Bal? I'm not seeing your comments here. Subhash is very fast today compared to others. Now the question is, for which value of k the root locus, in fact the poles of the characteristic equation lies in the left half of S plane. So what's the best way to do this problem? Anyway, first of all, find the characteristic equation. Characteristic equation is 1 plus g of s into h of s equal to 0. H of s is 1 here, unity feedback here, correct? So now look at that here, 1 plus g of s, of course k is there here, so therefore I can say k divided by s square minus 4 into s square plus 4. Just 1 minute, I am extremely sorry to take you back. Here, yes, we got the answer, but why no one has asked me a question, sir, how do you know that we need to use the differentiator? How do you know that you should use the differentiator? Can you think how I was thinking earlier? How I got the thought that, okay, integrator is failing here, how to use the differentiator? Do you know? I got this thought Somebody is asking, Siddiku, sir, which type of questions may be come in the HPCL and BHL? So in HPCL and BHL, less than gate, but I can't say that too much less than gate. Okay, not so many numericals, but you will going to get most of the easy questions. Like they will ask a very straightforward questions like what is the formula for angle of asymptotes, or what is the breakaway point, something like that. This is for gate standard. Okay, right. Now I am asking how we got this idea. We got this idea because if you can put a 0 here, that 0 can cancel with any of these three, then I can get only 2 poles in the net. Altogether net I can get 2 poles. That will bring plus or minus 90 degrees. That is the way how I thought this one. Clear? Right. One more. Right. So order will not. Yes. Very good, Rufina. Right. Now anyway, come to this question. So in this case, what will going to happen here? It will going to become like s square minus 4 into s square plus 4 all put together plus k is equal to 0. And this is also a wonderful question. In fact, you love this question. Just it will become s power 4 minus 16 plus k is equal to 0. This is called characteristic equation. Now I am asking a question to you. Do you think that this particular system will be stable anywhere else? Right? For what value of k, the closed loop system is stable now? Because the roots are lying in the left half of S-plane, means he is expecting that for what value of k, the closed loop system becomes stable. That is the actual question. That only it was twisted like for which roots lies in the left half of S-plane. Clear? So let's move ahead. So first of all, the characteristic equation, if you are clever enough, you can write down like this: s power 4 plus 0 into s cube, right? Plus 0 into s square plus 0 into s minus 16 plus k. Constant value is this, minus 16 plus k, equal to 0 here. So therefore, if I write this in this way, Routh array, so s power 4, s power 3, s power 2 and s power 1 and s power 0 here. Clear? S power 4 and s power 1. Unstable system. Soumya Bal is given the answer. Siddiqui is also given. Let me see. The question is, what value of k can bring this as a closed loop system? Let us see. S power 4 coefficient is 1. Rest again 0 here, and see 1 and 0, and then minus 16. Sorry, this is, I am extremely sorry, 16 minus k. Right? Or else you can say, 1 second. This is going to be, I am extremely sorry. It is here, of course, I should say minus 16 plus k, and that's what you will be having here, minus 16 plus k, right? And the next row you will be having like 0 here, so 1 0 and again 0 here, and then third one here 0. Clear? So that means I am extremely sorry to say that this is going to be considered as a all 0 row here. Correct? Of course, this is the all 0 row, right? This is the all 0 row, and the problem with this is this all 0 row states that there is a possibility of having a symmetrical poles. Correct? Now you do take any value of k here. Take any value of k. Take any value of k. You take k is equal to 1, you take k is equal to 2, k is equal to 3, k is equal to 4, k is equal to 5. Whatever the value of k you take here, you have to face all 0 row here. Clear? You have to face all 0 row here. If you have all 0 row here, then there are two possibilities. What are those two possibilities? Can you tell me? If you have all 0 row here, anywhere in Routh Haurwitz criteria, if you have a all 0 row, there are two possibilities. Either the closed loop system may be marginally stable, or the closed loop system may be unstable. Correct? Either the closed loop system is marginally stable or unstable. I am not going to say in this context what it will become. In general, I am saying that in case if you get all 0 row in the Routh array, there are only two possibilities suggest. One is either marginally stable system or unstable system. But what we require here, we strongly require only stable system. So when we strongly require only stable system, whatever the value of k you keep here, that will not bring the closed loop system to stable system. Clear? So this means no finite value of k can bring the closed loop system to be stable here. Clear? Have you understood what I mean to say? I hope you got the point here. Now the same thing, whatever I have explained with the RH criteria, now I will explain with the root locus. Aapko maja aa jayega. So you will really enjoy this. First of all, is this question is clear to everyone? Every one of you, please tell me in the comment section, is it clear to all of you or not? So that I will move to the next question. Next question is very interesting, that's why. Yes, very good. Very good. Other students? Aravind, other students? Yes. Right. Now, let me move to the next question here and put it in a simple word here. So, of course, assume that I have here that s power, s square minus 4 into s square plus 4. Same transfer function. Whatever the transfer function we have taken here, right? Whatever the transfer function we have taken here. So, the same thing I am taking, and I just want to show you what happens in the root locus. Right? What happens in the root locus? Now, s square minus 4 into s square plus 4. What are the poles here? So, if you technically see here, s square minus 4 is actually nothing but what? S plus 2 into s minus 2 here. Clear? And what is s square plus 4? It is nothing but s plus 2j into s minus 2j here. S minus 2j here. Clear? All put together, the same function can be written as a 4 poles. One pole is at minus 2 here. One pole is at plus 2. I am extremely sorry. This is going to be plus 2 here. Right? So, this is plus 2 here. Right? And here we have 2j and here we have minus 2j here. Clear? So easy to understand. There is no complexity. I have just taken this and expressed the pole 0 plot of the open loop system here. Now, the question is, yes, we do agree with this. But the question here is, first find the segments on which the root locus exists. And second is find the breakaway point of the root locus, find centroid, and of course so many things are there here. One by one we will see so that we can validate our data with the previous analysis. What was your conclusion here? Your conclusion is for this system, that means the same system, RH criteria is saying that whatever the finite value of k you keep, the closed loop system will not become stable. Now let's analyze the same thing from the root locus and try to tally this one. So then you will feel really interesting. So for that, let's try to answer the first question. Find the segments of the root locus on the real axis. Where are the root locus segments here? This is 2. This is 2 plus 2. Tell me. So on the real axis, suppose if you take any point right side to this point, how many poles are there? Only one pole is there. Correct? Only one pole means it's an odd number. So that means from here to here, this entire segment is there on the root locus. Correct? So you might be knowing that. Just stop a point, keep a point here, right side to that point, look at the number of poles plus zeros. Number of poles plus zeros, if it comes to odd number, then that segment will be there on the root locus. This is the basic thing. I feel that every one of you know this, right? Now I am asking that here, particularly in this case, if you take any point here, right side to this, we have 2 poles and 3 poles, third pole. So sum of open loop poles plus zeros here, 2 plus 1, 3, means right side to this we have odd number of points. So therefore this is there on the root locus. That means I can say all put together here, this is also there on the root locus. That means I am sure from here to here, everything is there on the root locus. Clear? Everything is there on the root locus. Then how do we say? Yes, of course, from here to here, this is there on the root locus. But what was the question? Question is, look at the most beautiful question here. Yes. So first question is completed. That is, find the segment of the root locus on the real axis. On the real axis, we have found that between these 2 points, we are going to have root locus. But what is the second question? Find the breakaway points of the root locus plot. Have you got any one of you calculated the breakaway point here? Mast maja aa jayega. So please see what is going to be the root locus. I mean like breakaway point. How do we get the breakaway point? First of all, characteristic equation is what? 1 plus g of s into h of s. Of course, k must be there here, is equal to 0. Right? See, from this concept, I will connect it to the gain margin and phase margin. Okay? So from this concept, we will see the gain margin and phase margin in tomorrow's session from the same lines. So please have brain, think logically and tell me. Okay? So here 1 plus k into g of s into h of s. What should I say here? 1 plus k divided by s square minus 4. Of course, s square minus 4 into s square plus 4, that would be equal to 0. That is what we have seen here. Correct? So from here, what should I say here? Of course, this is going to be s power 4 minus 16 plus k, that is all the way it is equal to 0. Am I right? Or somewhere it is missing here. Right? So this is all the way we got like s square power minus 4 into s square plus 4. Yes, yes, yes. Good, good, good. So we need to find the breakaway point. Anyone got the breakaway point here? Anyone got the breakaway point? So now we can even still take this one like this. K keep this side and minus of s power 4, and then it will going to become like, one second, minus s power 4 and minus 16 here. Correct? Minus 16 here. Now if you want the breakaway point, to find breakaway point, what we should do? Find breakaway point. Usually at the breakaway point, root locus will come and meet together. So when the root locus come and meet together, what will happen? Its velocity will going to become 0 at the collision point. When the root locus branches are meeting together at the point of contact, velocity will become 0. Here the velocity is nothing but the variation of, inverse of the variation of the root locus plot with the sensitivity. So in fact we say that that is dk by dx. Probably you people know this, correct? Dk by ds should be equal to 0. What does it mean? If you differentiate this, then it will become like minus 3 times of s cube. That would be equal to 0. So how many breakaway points you will going to get? Of course, if you equate it to 0, you will going to have only s is equal to 0. This is considered now as a breakaway point here. Clear? This is considered as a breakaway point. Excellent. Very good, Rufina. Very good. Where are the other guys? Arvind Reddy. Arvind Reddy, where are you? Right? So that means this root locus plot may come up to here. Right? This root locus plot may come up to here. Correct? So they both meet together, and here you will going to get 0. Breakaway point is this now. Clear? So this is considered as a breakaway point. Excellent. No problem. This is breakaway point. But you must also think in the reverse way of the same thing. This is breakaway point. Can you guess what is the centroid here? Right? Look at that. How do we get the centroid here? So now let me show you the centroid here. So centroid. Centroid is nothing but the meeting point of the asymptotes on the real axis. Correct? So how do you get the centroid here? Sigma is equal to sum of the poles minus sum of the zeros divided by number of poles minus number of zeros. So tell me what are the number of poles, sum of the poles here we have only 4 poles here, right? So minus 2 is 1 pole, plus 2 is 1 pole, 2j is 1 pole, and minus 2 is 1 pole. This is called symmetry. Clear? This is called symmetry. And when we have this kind of symmetry, we will be getting all zero row in the RH table, Routh table. I think you are able to correlate this. When we have symmetry in the pole 0 plot, then we will going to get all zero row here. And when we have symmetry for every value of k in the root locus plot, for every value of k, you will going to get all zero row here. Clear? So see the connectivity. Enjoyed, right? So now you see whatever may be the value of k, you keep here, right? So you keep any value of k. It doesn't matter for this, right? Sigma will be how much? Plus 2 and minus 2 and plus 2j and minus 2j. So we need to add all poles here. Anyway, there are no zeros here, so I am not so worried. And here we are going to have 4 minus 0. 4 poles minus 0. And what is the value here? So obviously this will be equal to 0. So what does it mean? It means that the centroid is also lying at the same point. Correct? Centroid is also lying at the same point. When the centroid and the breakaway point, when the centroid and the breakaway point, when the centroid and breakaway point both are same, then what will happen? Any one of you? Any one of you? Asymptotes itself will act like a root locus branches. Asymptotes, it will act like a root locus branches. Clear? When centroid is equal to breakaway point, asymptotes themselves will act like a root locus branches. Right? Yes, correct, Arvind Reddy. Yes, it's in all pass system. Right? Now, if you look at the angle of asymptotes, we all know that 180 degrees odd multiple. So that is 2k plus 1, right? Whole divided by p minus z. What is p minus z? That is equal to 4 here. Correct? So the value of k all the way where k can be 0 or 1, 2, 3. Usually it is p minus z minus 1. 4 minus 1, that is 3. Up to there the value of k will take place. Now can you tell me angle of asymptotes is how much? Any one of you? Please help me here. What is the angle of asymptotes here? Angle of asymptotes is equal to 180 divided by 4. That is nothing but plus or minus 45 here, right? So 45 into 0, 45. So I think you will be having like 45 degrees and 90 degrees here, right? And then 180 degrees here and then 225 here, correct? So now if you look at the, all the way the angles like this, how does it means? So moving ahead, the angle of asymptotes, you have got like 45 and all this stuff, right? So 45 degrees means obviously there is one angle of one asymptote is like this. This is 45 degrees here. Look at the crazy part. This is right 45 degrees. And then I think I somewhere missed this. Right, 1 second. Did I miss anywhere here? So 45, when you keep like k is equal to 1. So 45 into 3. I am sure, I am extremely sorry. Here you will going to have 135 degrees here. I am extremely sorry. 135 degrees here. I am extremely sorry. Clear? So no one has given the answer here. Right. So just see the angle of asymptotes here. As I was saying, when we keep k is equal to 0 here, you will going to get 45. And when you keep k is equal to 1, 45 into 3, you will be having like 135 degrees here. And then when k is equal to 2, so 5 into 45, that will be equal to 225 degrees. What would be the last one now? Any one of you? So when you keep k is equal to 3, 7 into 45, 7 into 45, that is going to be equal to 315 degrees. I am extremely sorry. This is the angle of asymptotes, right? So yes, Arvind Reddy, I have changed it. So please see. Now this means 45 one angle here you will going to get, and the next angle you will be getting like here. So this is going to be 135 degrees here. Fine, I am completely okay with that. And the next one is going to be 225 here. So this is going to be 225 here all the way. And of course this is going to be 315 degrees here. Clear? 315 degrees here. So these are considered as asymptotes now. So whenever we have a symmetrical or all-pass system or symmetrical poles around both negative real axis and positive real axis, obviously this is what will going to happen. Now as I explained this, now I am erasing this one, these angles here, otherwise it gets a lot of confusion here. So let me move this one. So this is angle of asymptotes. Clear? Right? Now I have last question to every one of you. We got like breakaway points and everyone is happy with this, right? But what about these 2j? These are the poles, right? Complex poles here, complex conjugate poles, right? When we have complex conjugate poles like this, they will also come out like this. That means complex pole. Root locus branch will start from the complex pole. It will go away from the complex pole. It will go away from the complex pole. That means whether the root locus branch will come like this or come like this or come like this or come like this, or in what way it will going to come out of this. In what way root locus branch will departure from the complex pole. In what way root locus branch is departure from the complex pole? How do you know that? Any one of you? How do you know that? How we can get that information? In what way root locus branch will going to come out of the complex pole or departure from this one? How do we get that? We can get that by using angle of departure here. Clear? So therefore angle of departure must be calculated here. Angle of departure. Clear? Angle of departure, right? So what is the angle of departure? Can you tell me now? So the angle of departure here can be given as 180 degrees minus sum of the angles contributed by all other poles minus sum of the angles contributed by all the zeros. See, one single question is sufficient to understand all the concepts, isn't it? It is not about like how many questions you have solved. It is about how qualitative questions you solved. See, we have used like integrated, differentiator and so many things we discussed today, right? So that is the way how you should think, right? So now you need to find out the angle of departure. What we need to do? First of all, we need to find the angle of departure here means from all other points, try to write the plot here. Anyway, angle contributed by this will be equal to 0. Why? There are no zeros at all. There are no zeros at all. We have only poles here. So what should I say here? Phi d is equal to 180 degrees minus sigma phi p here, right? And moving ahead, 180 degrees minus the phase contributed by the first pole plus the phase contributed by the second pole and the phase contributed by the third pole here and phase contributed by the fourth pole here. Let us see what will going to happen. This is an interesting example. So let's say that this is the first pole here and this is the second pole here, and let me call this as the third pole here and let me call this as the fourth pole. Now tell me, what is the angle contributed by this pole at that pole itself? What is the angle contributed by this pole at that pole itself? Obviously it's a point, right? So therefore it cannot contribute any angle, so this will be equal to 0 degree. Clear? Right. Now second one, how do we get the second one? From here, draw a vertical line up to here, correct? Draw a vertical line from up to here, and then with respect to horizontal axis, how much angle this vertical line is creating? That is 90 degrees here, straightforward. I haven't done any great mathematics here, right? So therefore, angle contributed here, that is because of the second pole at first pole. Second pole at first pole, it is going to be 90 degrees here, correct? So now, no, Rufina wrong, and Soumya, you are also done the wrong mission, wrong calculation. Angle of zero will not be, angle of departure will not become 0 here, as of my guess. Let me see what it will become, right? Now the third pole, from here we need to draw a line here, and look at what is this one here, 5p3 I am saying. So how much this will be? From here to here, this value is the 2 units, and from here to here, this value is also going to be 2 units here, correct? 2 units. Then what is this value here? 5p3. 5p3 I can say all the way it is equal to tan inverse of opposite by adjacent. So that would be equal to 2 by 2, that is equal to 45 degrees here, correct? So here, this angle should be written now as a 45 degrees here, correct? This is equal to 45 degrees, clearly. And what about this one here? Okay, so this one, that means from here to here, and we require this angle here, correct? This angle, or we can say, in fact, instead of this, we have to get this angle actually, in fact, correct? So this is considered now as a 5p4. How much this value? Yes, Arvind Reddy, good. So 5p4 is going to be how much? So this angle I can say again 45 degrees here, 45 degrees. And as I was saying, this is 45 degrees here, because this is also 2 here. And what is this one here? This is going to be 180 minus 45, 135 degrees here, correct? So therefore, this could be taken as 135 degrees here. So all put together, how much you will going to get here? If you see 180 degrees minus 0 degree plus 90 degrees and plus 45 degrees and then 135 degrees here. I'm very sure this 180 and this will get out here, and you will be having minus 90 degrees here. So that is considered as the angle of departure at first pole here, minus 90 degrees. Good, good, very good. No one is leaving the class. Almost everybody is there still up to now, right? So this means after this much of hard work, what should I say here is, look at that. Angle of departure here, okay? Angle of departure here is minus 90 degrees here. So that means if I say minus 90 degrees means all the way this is going to be this one. In fact, 90 degrees this side. So that is minus 90 automatically. So this is the way how this root locus branch will come here. So I can say all the way, this is the way how it will go into departure here. And the crazy part is, let's say that this will come up to here. And at the same time, you must understand, this is going to be how much? This will going to make pi d2, if you see 90 degrees you will going to get, okay? So here it will be of minus 90, here it will be of plus 90. So this root will all the way, it will travel in the upward direction with the same velocity, because we all know that the root locus is symmetrical about the real axis. When the root locus is symmetrical about real axis, if the first angle of departure at this, if it is minus 90, it will become plus 90. Clear? So it's going to come up, it's going to come down. Then what is the beautiful point that lies here? So let me remove here. So these two are okay, fine, no problem. And what about the other two root locus branches that are coming? They are coming like this. One is coming like this and another one is coming like this. And this is the beautiful thing here. The great thing is, whether they are at the real axis or at the geometry axis, now all will going to come at the same pace. That's why everything will going to meet at the centroid here. Clear? So look at that. Breakaway point, you only told that the breakaway point is 0 here, correct? So this is the breakaway point here, right? And specially we understood that, look at clearly, this itself, it is a centroid also same, that is 0. And we have also seen that 4 asymptotes will be there here. This is one, and I can say this is the second thing here, and this is the third one here, asymptote, and this is another asymptote here. 4 asymptotes are there, correct? Now tell me how the root locus branches will going to live here now. Now all 4, from these two they will come and merge here, these two they will come and merge here. Now 4 root locus branches are merging together. 4 root locus branches are merging. All 4 will going to travel through the asymptotes. Why they will travel on the asymptotes here? Because the purpose of the asymptote is to direct the root locus branch, correct, to the minus infinity or plus infinity here, because there are no open loop zeros here. So this side also it will go in this way. That means the root locus branch all the way it will go on the like this, and here also it will go like this. Am I right? It will also go like this, and even this will also go in this way, isn't it? So why the root locus branches are traveling? Why the root locus branches are traveling along the asymptotes? Any answer from your side? Subhash, Aravind, Rufina, where are the other guys? Rohit and all. Why the root locus branches are traveling on the asymptotes? The answer is, what was the answer? Why the root locus branches are traveling on the asymptotes? The answer is centroid equal to breakaway point. Clear? Centroid equal to breakaway point. That's why it is all happening here. Clear? That's why it is all happening here, that we will be having in this way, root locus. I hope you understood this. So please let me know, is it clear to all of you? Right? I want to give one question to you. If you say yes, I will just give one question as a homework. You can try for that. So I think today we discussed more I think. Right? Yes. Because of centroid and breakaway point, both are coincide here. That's all. So that is all about the basic idea here. In fact, what I want to ask here is, when k is equal to 0, so when k is equal to 0, that means this is one pole, and even this is the location of this pole, k is equal to 0, and this is k is equal to 0 once again, and even this is also k is equal to 0 here. K is equal to 0 here. Now can anybody say what is the gain at the breakaway point here? Right? What is the gain at breakaway point here? Gain at breakaway point. Right? So at s is equal to 0, I am asking what is the breakaway point here? What is the value of k? K is how much at breakaway point? Clear? K is how much at breakaway point? Can any one of you do this? Think logical and tell me fatafat. So if you want, this is the breakaway point. First of all, what you need to do here is, right, so let me take here, this is the breakaway point here, right? So I am saying that this is the breakaway point, and I need the value of k here. Whenever you want the value of k, the single solution is draw the vectors from every pole and zeros, right? So this and this, right? So this will going to have a length of how much? 2 units. This will have a length of 2 units, and this will have a length of 2 units, and this will going to have a length of how much? 2 units. Now tell me what is the value of k? K is going to be equal to k can be written as length of P1 mod, P2, P3 and P4. Of course, there are no zeros anywhere, right? Usually you should write like modulus of Z1, Z2, Z3 like that. As there are no zeros, we will write like k is equal to 1. And then what is k here? Get it fast. So the distance from pole 1 to breakaway point. This is pole 1 we have seen, and this is pole 2 we have seen, and this is pole 3, and this is pole 4. Correct? So the distance from here to here, everywhere, it is 2 units only. 2 into 2 into 2 into 2, that is divided by 1. Of course, this is equal to 16. Correct? So that means k is equal to 16. Very good, Arvind. Very good. K is equal to 16. This means that at breakaway point, k is equal to 16. At breakaway point, k is equal to 16. Clear? Breakaway point, k is equal to 16. Now, if you really want to enjoy the problem, what you can do is, for the same question, right? For same question, okay, find gain margin for this system. I am repeating, find gain margin for this system for k in between 0 to 16. Clear? Right? At the same time, find gain margin for k, greater than 16. Clear? For k greater than 16. Can you guess anything what will going to happen? Any one of you, can you guess anything what will going to happen? First of all, one must really understand that whatever may be the value of k we keep, right? Whatever may be the value of k you keep, whether you keep the value of k in between 0 to 16 or k greater than 16, I'm very sure k 0 to 16, if you keep like k, that means controller gain 0 to 16, what will going to happen? This root will all the way travel like, because here k is equal to 16, am I right? Here k is equal to 16. This root locus will try to come this side, this branch, and anyway this is there in the left hand side, no problem with this one, this is completely alright. And at least this is there on the imaginary axis, this is also okay. And this is also there on the imaginary axis, this is also okay. But this branch, the fourth branch here, right, it is in the right hand side of the S-plane. For what value of k? For k is equal to 0 to 16, correct? As this branch is there in the right hand side of S-plane, for this value of k, the closed loop system CLCS is unstable. Yes, of course, I agree that unstable. Clear? Unstable. Agree with me, right? Unstable. Now the most beautiful point is, even if k greater than 16, what will going to happen? K greater than 16, it is really worst thing here that even if k is greater than 16, think logically, how many branches will be there in the right hand side now? K greater than 16, how many branches will be there in the right hand side? Any one of you? So k greater than 16, now after breakaway point, one root locus branch is completely there in the right hand side. This is also there in the completely right hand side only, and two are there in the left hand side. This is there in the left hand side and this is there in the left hand side. Means this is okay, this is okay, but this is the problem. Now this is there in the RH side and this is there in the RH side, correct? What does it mean? It means that for k greater than 16 also, this is unstable only. Closed loop system is unstable. Again I am repeating, closed loop system is unstable. Closed loop system is unstable. But what is the actual logic behind this? Soumya, Aravind, Subhash, Rufina, Prakash, all of you must tell me now. What is the logic behind this? The logic is, there might be so many questions. There is no limit. There is no limit. Every time one question only comes from the root locus. But how do you solve that question? That is important, right? So now tell me, when k is actually between 0 to 16, you understood that how many root locus branches are there in the right hand side? Right? How many root locus branches are there in the right hand side? We have, right, only one root locus branch. RLB means root locus branch in right hand side of the S-plane. Correct? Right hand side of the S-plane. Correct? But k greater than 16, how many root locus branches are there in the right hand side? Right? So root locus branches here, number of root locus branches equal to 2 on right hand side of the S-plane. Correct? Right hand side of the S-plane. In fact, I can say during this time, right? During this time when k is 0 to 16, one root locus branch is there in the right side and 3 are there in the left side. And when we have k greater than 16, we can say 2 are there in the left side and 2 are there in the right side. Now tell me, relatively which is better? One thing it is sure that whether k is in between 0 to 16 or greater than 16, definitely at least one root locus branch is there in the right hand side of S-plane. So the closed loop system is unstable. It means that for any value of k, closed loop system is unstable only. Closed loop control system is unstable. But what I am asking is, when I break that like 0 to 16 and 16, I am able to see a difference here. The difference is 0 to 16, only one root locus branch is there in the right hand side. 3 are there. I mean, 1 is there on the left and 2 are there on the imaginary axis. And here 2 are there in the right side and 2 are there in the left side. So relative stability will going to change. Clear? Relative stability will going to change. Though they are unstable, in both the cases, relative stability is different. Clear? Relative stability is different. So what do you mean by relative stability? So it is as simple as that. So Pakistan border and I am in the Bangalore, right? So relatively I am so stable compared to a person who is there in the Rajasthan. Correct? Rajasthan, a person who is there in the Rajasthan, he will be near to the Pakistan border. Correct? Are you understanding? So that is, see, which is more unstable. Very good. GATE aspirant. Excellent. Right. So that means relative stability concept comes like this. Relative stability concept comes like this. Now the beautiful point is, even though we know that for this K and for this K, for both the case, K is unstable, but relatively which segment is stable? To understand that, we have to go for gain margin and phase margin. Clear? That we will going to discuss in the tomorrow's lecture. So first of all, you tell me, have you really enjoyed this class or not? Okay, have you got any new things in today's lecture, or have you understood a different way to think the same things what you have studied? So please mention in the comment section, right? So to understand the relative stability, we have to move to the gain margin and phase margin. Clear? Yes sir, a lot. Okay, thank you Soumya. That's why you should not miss the classes generally, because I love the control system. I enjoy lot many things to do this, and I want to tell all these things to you. So at any cost, don't miss. Other students, you have to message, have you learnt anything new in the today's session or not? Have you learnt anything new? Have you enjoyed it? Right. Now the same question, whatever you have solved here, you try to take the K value here. K value, if you keep 16 here, look at what will going to happen. K is equal to 16 if you keep, then all the way S power 4 is equal to 0 you will going to get here. That is enjoyed a lot, right? Op-amp concept with CS, very good, right? So more idea we got, very good, nice. So now I told you that from the root locus we have segmented that all the way that see here, one second, K 0 to 16 and K greater than 16, correct? So that means K is equal to 16, something is happening here. K is equal to 16, something is happening. What is happening at K is equal to 16? Can you tell me now? Can you tell me K is equal to 16, what is happening? Any one of you? Why we come to a K is equal to 16? From where we got that K is equal to 16? We got K is equal to 16 by considering the breakaway point, correct? By considering the breakaway point, right? So at breakaway point we got K is equal to 16. But have you noticed that at breakaway point when K is equal to 16, how many root locus branches are meeting together? How many root locus branches are meeting? This is coming all the way like this, correct? And this is coming from this side, and this is coming from this side, and this is coming from this side. 4 roots are meeting together at K is equal to 16. At K is equal to 16, 4 are meeting together, correct? That is actually very good, right? No, system here, it will not become stable anywhere. Here system will not become any stable. I just calculated at breakaway point, K is equal to 16, we got it. At that point, this root locus branch came here, this root locus branch came here, this came here, and this came here. All 4 branches are meeting together, correct? That means 4 roots are there. There are 4 roots of the characteristic equation are there exactly at the same location when K is equal to 16. When K is equal to 16, 4 roots of the characteristic equation are there at S is equal to 0. Roots are equal. Very good, Arvind. And that is what even your RH criteria is also saying. Where is that RH criteria? One second. Right. Even see here, Routh Haurwitz criteria. When you make K is equal to 16 here, what will going to happen here? So that 16 and this minus 16 will cancel out. And characteristic equation, now it will going to become what? Characteristic equation, it will become like S power 4 is equal to 0. Correct? That means there are 4 roots at S is equal to 0. That is what Routh Haurwitz criteria is saying, and the same thing even root locus also have done the, explained the same thing here. Clear? So that's how the control system subject is really a wonderful subject. I mean to say it is one of the fantastic subject where you can correlate the concepts and you will really love it. One single question is sufficient to understand multiple concepts in n number of ways. For that you require the guts to understand, at the same time you should love the subject, okay? You should love the subject, right? So however, this is a homework question to you and you can take this as a homework question, and I sincerely advise solve this question, and once you solve this question, keep the answer in the comment section after the class. Hope you really enjoyed the class here. So finally, of course, so I'm sorry. Right. So with this, I have completed the class. Hope you really enjoyed all the way together. Oh, today also I lost this data. Right? But anyway, this is the homework question. And those students who are really interested to solve this question, so you can take this as a homework question. Once the class is completed, then please keep the comment in the comment section. So I hope you really enjoyed this class. Arvind, today also I just discarded this, whatever I have written that was erased. but I can send this PPT if you want. Okay, so guys, let's sign off for today. Tomorrow we will going to meet at the same time 9 o'clock, and we will going to discuss gain margin and phase margin, and that also you will going to see completely in the different way. I know that I am discussing little bit deep in a multi-conceptual way because this is a champion series, correct? So hope you all are enjoying, and we'll meet sharply at 9 o'clock tomorrow. Thank you once again.